Well, hello guys, welcome back to John's workshop, and in this video we're going to carry on with the fitting of the DRO to the milling machine, and we're going to concentrate on the Y-axis. So we've got the Z-axis and the X complete now, other than a bit of cabling work to tidy up, and we're now going to start on the Y-axis. So I'll bring you in closer and show you roughly what I'm planning to do, and then we'll crack on with the machining various bits and pieces and start getting the Y-axis ready for fitting to the side of the mill. So you can see the side of the mill here. I need to fix the scale to either the base, which is what I'm going to have to end up doing. Another option would be to try and fix the scale across the end of the sort of carriage here, but I can't do that because obviously at full extremes of travel of the X-axis, the carriage and the handle go between here, so I can't bridge across between these two bits of casting here because it will just foul on the X-axis and restrict my ability to use all of the axis capability that I've got. So the only option I've got is to fit the scale, and here is the scale still bagged up. So the only option I've got is to fit the scale down here onto the side of the casting at the base, and then create a bridge from the reader head up in a very similar way to what I've done on the X and the Z up to this point. Now that's going to be quite a long bridge. You can see the distance between there and the underside of the reader is almost 6 inches, so it's going to be a big ugly bridge unfortunately, but it's the only real option I've got. I could shorten the bridge by fitting the scale upside down, but obviously I don't want to do that because that exposes all the insides to the swarth and mess, so it's going to have to go this way round, fixed to the base, and a bridge created up. So that's the plan. How we're going to do that with the Y-axis, I've got the as supplied backing plate, which we will need to fix in this way round to the side of the casting down here. Now you can see this casting's just, you know, it's all over the place. It's not flat, it's not straight. If I try and take a, you know, you won't be able to see from the angle the camera's at, but that's probably about 15 degrees slope on there. So it's all over the place, so this is going to be a really difficult one to do. So what I'm going to do, lessons learnt from previous scales, is on this backing plate here I'm going to drill top and bottom of this screw hole and thread it for a grub screw to fit in, and both, and the same this side. Now I can't get top and bottom of this hole where the counter bore is, so I can get one at the bottom, and the top's going to have to be slightly offset to get enough room to fit it in potentially. I'll have a look, but I don't think I can squeeze an M4 in that tiny gap there. So, and then what we'll do is we'll use those grub screws in conjunction with the clamping screws to be able to take that 15 degree slope out and also balance it this way by switching all the grub screws around to get it set how I need it, and that's going to be far easier than faffing around with bits of shim and packing and all the rest of it. So that's what we're going to do, that's the plan. In terms of the bridge, I've looked at this. Obviously I need to come off something either on the carriage, well on the carriage it's all I can come off this carriage area here. So in keeping with what I've done with the X-axis, I'm going to use an offcut of the same 42mm bar that I've got here, a VM1A. So we'll face that off, get rid of the hole in the centre, and I've taken some rough measurements. I'm basically going to use a section of this with a hole all the way through, counterboard with an M8, you know, big M8 cap head screw in there. That will clamp nice and tightly to there, and then from that point onwards I will then revert back to aluminium, my 10mm aluminium plate, to drop down and create the bridge underneath the reader, and I think that's probably about the best I can do. Again, I'm restricted here, I can't come any further inboard of of the V here, because obviously as the X-axis comes back out it needs to clear that corner. I know you can't see, I'm pointing at things that you can't really see. Let me use a pointer. So hopefully you can see there the sort of V from the X-axis. Obviously I need to clear that corner, so I can't encroach on that axis in any way. So this 42mm just about clears that. If I fix that in this sort of position, something like that. So I've taken some rough measurements of how long this needs to be. So this needs to be 50mm length. I might go slightly longer, I might go 51, 52, unimportant really. Just needs to be long enough to get far enough out to clear the scale and the scale cover. So I've taken some measurements. So the first job, we'll go to the lathe and we'll make this space up. Okay, so we'll get this piece chucked in the chuck. Shall we say put in the chuck? That sounds better, doesn't it? So I've whipped this round in the chuck, the part, giving it a quick clean up just to get the surface rust off. I've locked my carriage off, we've got the parting off tool in, and we're just going to part off this excess piece on the end. I've left myself plenty of stock. So we'll have another go with the parting off. We're going to go at 800 RPM. I don't know whether the through hole I put in, I didn't really measure how deep I went, so I might be parting all the way through this right to centre. So we'll give that a go. Now I've taken the billet out the chuck because I want to face this and make sure it's parallel. So same deal as before with the X-axis. I've cleaned all the chuck up, all the jaws, the back face of the chuck's clean and the parallel's clean, and I'm just going to drop the part in there now up against that parallel. Just make sure it's all clean. Pull the parallel out. So we're over at the mill, and the next operation on this piece is to put 4 holes in, equally spaced, 90-degree spacing, into this top face, drilled and tapped. I've not decided yet. M5 I think is probably what we're going to go for. So we've got the clock in the dovetail clocking holder, and we've got the part sat in a V-block up against a fixed jaw. So the first job is to clock this in and find the true centre position of this diameter piece. So I've zeroed out there. We're minus 5 thou. Plus 15 thou at the back. So if I bring that back to about 12. So we're plus 4 at the front. Plus 5 at the back. Plus 5 at the front. And how you use these, the easy way, once you've got it right front and back, because we're clocking something we know is round, go to the 90 degrees position and just make that the same value. Plus 5. And that should be us 0 all the way around there now, near enough. Yeah, it's reading plus 1 all the way around. So I'm going a bit mad with the spot drill there to try and save me an operation with a countersink. I know it's 60 degrees and not 90, but for what this is, that will be fine. There we go. That's that component complete. So next job I need to do on that is just clean it up, degrease it, drop it in the chemical black, and then that's ready for fitting to the side of the machine, and then we'll start on the aluminium pieces that are going to interface with that. So just a final point on this. You can see, well, a couple of final points there. You can see the countersinks created by the spot drill. I do like to see a nice, where there's room in the material, a nice healthy countersink at the top of threaded holes. And it's always, you know, another tip, it's always best to put the countersink in before you put the tap down, because if you tap it first and then countersink it, you roll the top thread over into the threads, and then you really need to run the tap back down it. But if you do it this way, nice big healthy countersink, bigger than the major diameter of the thread, in this case a lot bigger, it leaves a really nice looking piece when you're done, and you don't have to go back down with the tap to take rolled over threads out. One last piece on this, you'll see when I counterbored this in the lathe, I went 8mm deep. On a bit more thinking about this, I checked what M8 bolts that I've got, cap heads that I've got to screw through this into the saddle, and the only ones that I've got here are quite shortish. So basically I loaded it back up in the lathe, and I've just deepened that counterbore, which doesn't matter at all, but that'll be absolutely fine for the M8 cap head to sit right down inside there. And I've got about 25mm thread sticking out the back to fit into the casting. So that's the first bit of the Y-axis complete. So we're going to start on the next stage of the jigsaw puzzle for the Y-axis, which is the backing plate. So we'll get that in the vise. We've just got a couple of parallels in there just to set it up, and then we'll remove those parallels so that we're not drilling into them. So we're all set up there, ready to go. I'll get my drills, taps and everything else I need, and we'll come back and pop those holes in. I'm not setting anything up with this. There's no mating holes for this to go in. These are just going to go in by eye, and that's going to be more than good enough. There we go, that's got our two holes in that end, and 2 holes in that end for the jacking screws by hook and by crook. The M4 tap is right on the limits of snapping, even in aluminium. This stuff's really, I don't know what grade of aluminium it is, but I can't imagine it's anything special. It's really quite sticky. So but we got there. So we'll set up now, get the mill in the right place, and start to see positional wise where this is going to sit on the main casting. Okay guys, it's time to fit the bush or the spacer or whatever you want to call it that I've made there to the end of the bed in this location here. So what I've done, I've obviously chemically blacked that since you last saw it. This is going to be as rough and ready as you like. Basically going to position this in the right place where we miss the axis, but to get the maximum amount of location, which is probably somewhere like that. And I've got an 8.5mm drill, which is the size of the hole that we've put through the centre. So we're just going to spot the casting with this, hopefully. Yeah, you can just see that spot there now. So the next job now is to get a hole drilled in there and tapped for an M8. So I'll bring you back when I'm doing that. So we've cleaned that face off, we've cleaned the back face, just made sure it's clean of the spacer. And this is where we find out whether the hole moved when I drilled it, or whether it's going to clear the table. It's very close. We've got plenty of thread in there. I don't think that's going anywhere. Nice and solid. So I just need to check now whether, as the table comes back out, it clears that, because that is really close. I'll just check that now. Just put the handle back on quickly. Moment of truth. Oh yeah, loads of room. Yep, perfect. So the next job now is to clean up from drilling that hole and tapping it. We'll bring the scale and the backing plate into position. We'll wind the y-axis fully forward to its end of travel, and we'll work out where the next 2 holes need to be drilled into the casting base down here to support the backing plate.